In this video, I'm going to discuss what a piecewise defined function is. And a piecewise defined function is just a function that is graphed on specific domains. So you're graphing different pieces of different functions on a specified domain. And when we talk about a domain, we need to remember that the domain itself, the domain is equal to your x values. So when I'm graphing a piecewise, what I'm really doing is I'm graphing along this x-axis here. I'm looking at the x-axis. And for each part, I'm going to graph whatever the specified part of the domain is. And I'm only going to graph it on its specified domain. So if I look at this particular graph, for instance, it's defined as f of x is equal to -4 when x is less than or equal to 2. Well, -4 is just a constant function, or just a line at -4. And so this is just a constant function. And all we're going to do is, I'm going to show you this one in blue, what it looks like. So I'm graphing this part of the function at x is less than -2. So here, if you look at -2, that would be right here. So less than -2, you notice that it's just at the value, the y value of -4. It's this constant function here. That's what's happening. And it tells me to include it on this particular value, by the way. So when we want to show inclusion in a graph, we generally draw a closed circle. That means we're going to include the value of -2 on that function. And because these functions are what we call a function, in a function, the x values can never repeat. This is a continuous function, so you can only define one x value on one particular part. And what I mean by that is, if you look here, -2 is defined in this first one, but then you see it again right here. But notice that this symbol is missing the equal to part. And that's because it can't be equal to here and equal to here, because your x's would be repeating. So in the next function, let me grab that in purple. On the next part of the function, what we see is that it's x minus 2. So this is just a line with a slope of 1 over 1, and the y-intercept is -2. So notice the y-intercept -2, and they graph the line with a slope of 1 over 1. And it's only defined, though, from -2 to +2. And neither of those values are on the line. So what we do then is we're going to, for that particular value, we want to show exclusion. We can go around and draw an open circle here and an open circle here. And that's this part of the graph that they're showing. And then the last part, I'm going to graph that in a green function. And on that particular part, we're graphing it for 2x plus 4 when it's greater than or equal to 2. And so they've already graphed 2x plus 4 for us. That's just another line, the slope of -2, and a y-intercept of 4. And they've only defined the part. And technically, if you were to graph this, you would plot the y-intercept at 4. Slope goes down 2 over 1 like this. So you would get this line right here. The line is doing this. However, the function's only defined when x is greater than or equal to 2. And because of that, at this particular point, at 2 right here on the x, we're only going to define the function when it's like this coming down here. That means that this top part of this function that I have up here will not actually be part of the function. It's not defined there. That's why it's called a piecewise defined function. So here's what you're going to get. And we can evaluate this function now based on specific x values, looking at the correct domains. And so if I want to evaluate f -4, you can look at this graph and you see -4 is here, and you see that's on the blue function. You can also come up to the specified domains up here and look at x. Well, -4, I'm only worried about x. This is an x value, by the way. Only worried about x. I want to know, is -4 less than or equal to -2, in between -2 and 2, or greater than or equal to 2? Well, -4 is less than -2. And so that tells me that when f is -4, the y value is going to be whatever this y value is right here. And so that's -4. F of -2, well, look, I have a -2 here in the blue and a -2 here in the purple. But only one of them, this is equal to -2. This one says it can be equal to -2. This one says it can't be. So again, this is going to be in the blue function. And again, if you go to your graph at -2, you're only connected right there. You're only going to be part of the blue function. That's when it's included. The purple function doesn't include it. So again, you're going to evaluate this at -2. I mean, at -2, when you look at that, that's going to be -4 again. F of 0, well, when we do f of 0 is going to fall in between -2 and 2. So it means you evaluate on this purple function. So you're evaluating at x equals 0, which is here. And you can see that that's equal to -2, but you can also do it from the function. To do f of 0, that means you're going to replace the x with a 0, and you're going to evaluate with the purple function again. That's because 0 falls in between -2 and 2. So when we do this, we get 0 minus 2 I'm using the purple function now. And I get that equal to -2. And that also corresponds again with the graph because we can see when x is 0, this value is -2. The last one, f of 2, well, you have a 2 here and a 2 here, but it's only equal to on the green function. So here I'm going to evaluate at the green function. I'm going to evaluate when x is 2. So that'll be -2 times 2, because that's what your x is, plus 4. Well, -2 times 2 is a -4, plus 4, that's equal to 0. And we can see that when x is 2, which is right here, the y value is 0. So that's how we evaluate a function, a piece of fine function. All right?